remember, it's what the first thing is on that stapled packet of notes I gave you, is how to graph a quadratic equation. And I guarantee the first 2 questions on your test tomorrow are going to be graphing a quadratic, not tomorrow, Monday, graphing a quadratic equation. So you have to know the y equals negative b over 2a. I have a reference sheet that I will give you on Monday. You're welcome to look at it. But it does not say the vertex is negative b over 2a. It gives you the quadratic formula, and it gives you the standard form of a quadratic. That's all that the ISEP 10 gives you. That's what I'll give you. Okay? Which means you have to know to find the vertex and the axis of symmetry is the equation negative b over 2a. This formula sheet will give you that y equals ax squared plus bx plus c. It does give you that, so if you don't know what a and b are, it does give you that, but you have to know this equation. On your graph, if you don't have your vertex labeled, that's going to be a big deal. So if I was going to graph this, that's where I'm going to start. I'm going to find my vertex, my axis of symmetry. So I'm going to do negative b, which is negative 2, over 2 times a, which is 1. Negative 2 over 2 is negative 1. So if I ask you, like number 1 asks you, the equation of the axis of symmetry, it's an equation. It should be x equals negative 1. That's the axis of symmetry. It also asks you for the x-coordinate of the vertex. I want you to find the whole vertex, but the x-coordinate of the vertex is exactly that. It's negative 1. So if you found the axis of symmetry, you also found the x-coordinate of the vertex, which is negative 1. I'm going to go ahead and write the whole point. And if you remember, if all you have to do to find the y-coordinate is you plug the x into that problem. And this is where we talked about using your calculator correctly, because when you plug negative 1 in here, if you don't put parentheses around it in my calculator, it gives you the wrong answer. Because negative 1 squared is really positive 1. So if I plug negative 1 in here, I'm going to get 1. 2 times negative 1 is going to be minus 2 minus 3. Or 1 minus 5 is negative 4. That is my vertex. And if you're graphing, you got to have a vertex. So number 2 says graph a function, labeling the y-intercept, the vertex, and the axis of symmetry. So negative 1, 4, negative 1, negative 4, okay, I did it wrong, 1, 2, 3, 4, would be right here. You don't have to label your axis of symmetry, but I think it's a really good idea because it tells you where it's cut in half. Right? That's your line that cuts it in half. And then you just need to find one more point. That one more point, hopefully, could be the y-intercept. Because the y-intercept is when x equals 0. Or really nicely, it's what your c value is. So looking up here, I know my y-intercept is negative 3. So that would be right here. And what we love the most about parabolas is that you can flip it over and you get that point right there. And if you're just graphing it, that's all you really need to graph it, right? Like you can make your little parabola, make sure you don't make it too pointed because it's supposed to be rounded, smooth edge. And that's how you can graph a parabola. If we were going to solve this by graphing, we would want to know where it crosses the x-axis, which means we might need to pick some more points, or maybe we want to look to see if it's factorable. But graphing, vertex, axis of symmetry, y-intercept. Make sure you know if it's positive x squared, it should open up. If it's negative x squared, it should open down. Number 3 says, determine the maximum or minimum value of the function. That's the whether which way it opens, and the maximum or minimum, just like in that packet that I gave you, there's this whole section on max and mins. It happens at the y-coordinate of the vertex. So you should at least be able to, especially on this being multiple choice, the fact that this is a positive x squared tells me that it opens up. So is that a maximum or that's a minimum? That's a minimum. So right away, you know that it can't be B or D. Now don't just guess from A and C. It's just the y-coordinate of the vertex. So I'm going to do negative B over 2A. That would give me negative of negative 8. So that's positive 8 over 2 times A, which is 2. 8 over 4 is 2. Don't pick C, at least not yet, because it could still be 2. But remember, this is the x coordinate. The max or min is the y value. How high up or down is it on my graph? So to get the y coordinate, I have to plug 2 back in there. So you have to know which way it opens. You have to know how to find the vertex. You got to plug that number back in there to find the y value that goes with it. And if I plugged 2 in there, that would be 4 times 2, which is 8, minus 8 times 2, which is 16, plus 9.
I was thinking that the 9 was the y.
Well, the 9 is the y-intercept, but if the max or the min does not occur at the y-intercept, it occurs at that vertex, right? Like it occurs at the turning point. And so that would be at 1 on your graph. And even if the test had a multiple choice question like that, I would highly recommend showing some work with that, because if you don't show work, I don't know how you got the answer, and I can't give you any partial credit. And so you need to get past the point of thinking multiple choice just means multiple guess and that you don't show work for it, because 90% of the time you're showing work with that. And then 4 and 5, I left you graph paper, because if you're trying to find the zeros of this, you probably need to graph it, unless it's factorable. That's the only way you could get away with this without graphing it. So it says solve each equation. If exact roots cannot be found, state the consecutive integers. And again, directions on your test are going to say just like this. Exactly the same way we did in the homework, exactly the same way we did in the notes. So the first thing that I would do is I would set it equal to 0. So I would subtract the 3 over. Solving means finding those x-intercepts, those roots, those zeros. If it is factorable and you can factor it, you can find the zeros without having to make a graph, which is what I think I can do on this one. Right? If I try to factor this, what multiplies to give me x squared is just x and x. What multiplies to give me 3 is only 3 and 1. And can I put those together to get the negative 2 in the middle? I would need a negative 3x and a positive 2x. Sorry, just kidding. Positive 1x. So the 3 has to be negative. The 1 has to be positive. Or what multiplies to give me 3, that subtracts to give me negative 2. Yes, Austin?
Quick question. How do you know that 3 is like minus 3? Why not plus 3?
Because I need a negative 2 in the middle, right? Like, what's the only way?
No. I'm saying, like, whenever you wrote it out, just like...
Oh, because I had to get it equal to 0. So if I want to move that over, I have to do the opposite, right? Like, the only way I can move it across the equal sign is to do the opposite. So since it's a positive 3 right now, I can't move it over unless I do the opposite to make it equal 0. Like, that's an equal sign right now. And if I'm solving this, right, it's equal to 0. So then I solve this. So I get x minus 3 equals 0, x plus 1 equals 0, and I get x equals 3, x equals negative 1. Which means if I can make that connection, then I know solving it means what I get when I set it equal to 0. I didn't have to make a graph to do that. I could have made a graph, but I didn't have to. So for number 4, I know the solutions without making a graph. Now the exception to that is like number 5. I can't factor number 5. I know already. I could try. If I make my 2 parentheses, I would get 7 and 1. I have to pick 7 and 1 because 7 is a prime number, and the only things multiplied to give me 7 are 7 and 1. Can I put 7 and 1 together by adding or subtracting to get 4 in the middle? Which means it's not factorable. That doesn't mean there's no solution. It just means it's not going to be a nice number, which is why it says if exact roots cannot be found, state the integers that it's between. Which means right now, up until we learn more stuff, we have to graph this. Okay, so this will be another one just like number 1. That I'm going to graph it by doing negative b over 2a. Right? That's the one formula that you have to know for the test on Monday. It's the only formula that you have to know for the test, other than knowing how to factor, which aren't really formulas. So I would get negative 4 over 2 times 1, or negative 4 over 2 gives me negative 2. Now remember, that's not my solution. That's my axis of symmetry, aka the x-coordinate of my vertex. So I know that my vertex is -2 something. And what's not so fun about graphing by hand is it takes a lot of work. It takes a lot of time. You can't just wing it. But you have to plug -2 back in here, and you have to plug it in correctly, either with the calculator or in your head, and get the y value that goes with that. So if I just do this part in my head, -2 squared, I know, is -2 times -2. I don't need a calculator there. I know that's +4. And then 4 times -2 is -8, and then -7. And then type that in the calculator, right? So don't worry all about the parentheses and the exponents. Maybe you won't make that mistake. Gross, that's a pretty small number, right? So that's -15 plus 4, -11. Did you get that? Is the vertex the solution? No, I have to graph it and see where it crosses my x-axis, right? Which is if I gave you one of these on the test, I would give you a graph to go with it. But this was a book problem, so they didn't give you a graph, which is why I left you graph paper if you wanted it. It's gonna be a whole other page here, but that's okay. So my vertex is -2, -11. So this goes to 10. So if I did -2, -10, -11, that would be my vertex. I could kind of draw my line down here. What's my y-intercept of this one? -7. It's the one without an x. So I could do that. 1, 2, 3, 4, 5, 6, 7. I could flip it over. Kind of looks like number 1. This is where I would pick another point because I don't want to just wing it because I don't know how wide is it going because I'm going to try to guess where it crosses. So I would pick another point. So maybe I would pick 2 or 1 so that I could kind of see like how quickly is it growing. So I'm going to pick 2 here just because I want to kind of see what's happening. And whenever I get over here, remember I can flip it over. Trey, you should stay awake. You haven't been in class for lots of days. It would be nice if you were awake on the day we're reviewing for our test. If I plug 2 in here, I'm going to get 4 plus 8 minus 7. 5, is that true? 4, 5, which means I can flip it over, 1, 2, 3, 4. And all that does is it kind of gives me guidance as I'm making my graph, right? Instead of just completely winging it. Well, how else would it connect? And how would it still go through that point? You see what I'm saying? Like, it's going to be roughly closer. As opposed to if you didn't pick that point, do you see how maybe, Austin, you might have made it go way out like this? Well, then I would make my line to meet over there.
So basically, it could be anywhere.
But it's not because I picked the point to make sure it's in the right spot. By knowing that the point 25 is on here, I know that it's not way out there because it has to go through the point 25.
Basically, you can pick any point, and then
if you do the math right, then that's going to tell you where to make your lines. Okay?
okay,
Right, so if I picked like 7 over here, if I pick 7, it's going to be way big. Because what's happening is this is growing out. As this goes up, it's going to keep going out.
So basically, what you're saying is if I just like drew the graph like with the 3 points that you had, and then I just like kept going and then put like a dot on any point, and then put that point on the x y table, because you can do it on the same side.
But it wouldn't be right. Like if you just randomly made a point, like if, oh my gosh.
Just pick a point, okay?
I just want to know if like
If you just winged it, I don't know if that's the right word or not, but let's say you did this and you're like, woo, it's like this, right? You made it way wider than it needs to be. And then you're just like, I'm just going to pick this point.
and then whatever that point is.
But no, that doesn't work. Like, because this doesn't work. If I did 1, 2, 3, 4, 5, if I picked 5 for x, it's not right because I'm telling you it's not going to be 4. I could check it. If I plug 5 in here, I'm going to get 25 plus 5 times 4 is 20 minus 7. So 45 minus 7, 30 something, right? That is not 38, which means you can't just make the graph first and then make your point. You can pick whatever x value you want to put on your chart, and you find the corresponding y value. Because the domain is all real numbers. You can pick any x you want, but you have to find the y that corresponds to this equation. And this does not correspond to it, which is why if you did that on your test, you would be wrong. But if you make your graph and it's far away from the x-axis, you can pick whatever x value you want. I picked 2. 1, 2, 3, 4, 5. The equation, it has to work in the equation. And the 0.25 works in the equation. So now I know that the point on the other side is also going to work. And if I guide my line there to go through there, it's going to be close enough to get me the right answer. So the answer here is, what is it in between? So x is in between 1 and 2, and x is between, let's see, negative 1, 2, 3, 4, 5, negative 5 and negative 6. All right, the zeros, where it crosses, which is what I would write up there. Solutions. That's why I love factoring, right? Someone said, how could you love factoring? I love factoring because it's way less work for me than graphing. Graphing is a lot of work. That's why factoring is my top 5 things that I like to do. Which is what the next one's here. Solve by factoring. So you have to get it equal to 0. So like number 2, let's do number 2 first. So just like the other one, you asked that question, Austin, how did I get the negative? This is a positive 45, so I'm going to subtract it over. So I would get plus 4x minus 45, and I could factor this. I'm looking for things that multiply to give me 45. I know I want a 4 in the middle. There's nothing in the front, so I can kind of just think about things that multiply to give me 45 that I could add and subtract to get 4. Should be 9 and 5. If it doesn't work and it says solve by factoring, you can say that it's prime. But if it's an equation tomorrow, Monday, it's going to work, okay? Doesn't that work? 9 times 5?
Yeah.
What's wrong, Austin?
You're overthinking things. Just listen.
I'm totally true. We're going over this problem yesterday.
Yes, and you didn't agree with it? What didn't you agree with?
We did all kinds of things.
It has to be 9 and 5, because you can check that 9x minus 5x gives you the 4x in the middle, and 9 times 5 gives you negative 45. If there's an equal sign, you should get the zeros. So you solve that, and on number 2, you should have said x equals negative 9, x equals 5. Or you could even just say negative 9 comma 5. Remember, those would be your x-intercepts. Those would be where it crosses the graph. Your solutions, your roots. Number 1 is the uglier one. Again, this is a little rough because it's not set equal to 0. I always like to keep my x squared positive. So if this were me, I would add 13x over and I would subtract 10x over. So I'm going to write this down here and then I'll probably go back and erase it. But I would write this as 3x squared. I would add 13x over and I would subtract 10 over. And this is where you have options. This is where the first time we did this, I showed you the rainbow, the factor by grouping method. This is where on Wednesday when I was here, I showed you how you could just make your 2 parentheses and you could kind of guess and check and do the smile and try to get it to match up. That also works, all right? But there's definitely going to be a couple of these on there because this is something that I want you to know how to factor. So since I just did the rainbow method a couple days ago, the smile method, I'll do the rainbow one on this just to remind you of the factor by grouping. This is where I say, let's change this to a factor by grouping problem. And I multiply 3 times negative 10, and I get negative 30. And then I ask myself, what multiplies to give me negative 30 that subtracts to give me 13? And this is kind of tricky because 10 times 3 equals 30 and 15 times 2 equals 30. One of them is when you're adding and one of them is when you're subtracting. So be really careful on that. Since this is subtracting, the only way it's going to work is if I pick 15 and 2. So I think you have to pick 15x minus 2x. Because 15 times negative 2 is negative 30, and 15 minus 2 is positive 13. And this is what we spent. We did a homework quiz with one question like this, factor by grouping. And then you bring down your numbers. So you bring down minus 10, you bring down 3x squared, and you group them together. The smile method also works, but you just have to kind of guess and check and get your signs right.
Wait a minute. Oh, okay.
Do it the other way.
No, I was wondering because we had to group it a different way on number 5 because you couldn't graph it or group it x's and we had to graph it because of the negatives. Or no, because it didn't line up right. I don't know how to put this.
The negatives didn't work out?
No.
I think this one does work out if you pick 15 and 2. Like I factored out a 3x from the first two. I want this to match, so I factored out a negative 2 from the second one. So that factors out to x plus 5 and 3x minus 2. Those are your factors. I want to set this equal to 0, so I'm going to solve it. So when I solve that one, right, it's just the opposite. So that's just x equals negative 5. But when I solve this one, it's okay to show some work there, right? 3x minus 2 equals 0. I can add the 2 over. I can divide by 3. Please don't give me decimals. X equals 2/3 is the answer you should give me. Imaginary number stuff is also thrown in here, so that's what number 3 is. Remember that simplify your square roots if you can. The negative gives you imaginary. Don't forget the plus or minus. So on this one, if you subtract 100 and divide by 5, you get x squared equals negative 20. You would take the square root of both sides, so you would get x equals plus or minus the square root of negative 20. The negative part is the I part, so you can always take out the square root of negative 1, and then you have to come up with the two numbers and multiply to give you 20. So 4 and 5, which is why the answer here is 2i square root of 5 plus or minus c should have been your answer.
After the x squared equals negative 20, like I know you're thinking like square root of that, just lost.
So if it's a perfect square, it's nice because it's just a perfect square. If that was a square root of 25, it's just 5i. But when it's not a perfect square, you have to think about going back to when you were at the end of Algebra 1, quadratic formula. You guys worked on simplifying square roots. And that's what this is. I don't want the decimal. I want you to think of numbers that multiply to give you 20. Don't pick 10 and 2. Pick one that's a perfect square. Okay? We'll keep working on that.
Sorry. You take like the square root first and then get 10 and then divide that by 5 and still get 2i. I mean, I just thought of that, so I don't know.
No.
You do another one.
I mean, like, if you square rooted that, it's still like, it'd be 10 and then you'd have to get.
But you can't square root addition subtraction. It's not true. Because you'd also have the square root of 5 here, right?
Yeah.
So then you would have 10 divided by the square root of 5 when you solve that. That's not going to work. But yes, well, number 6 is like that too. So we'll do that in a second. Okay, so this was C. Number 4, number 5. We're running out of time very quickly, so I'm not going to do both of these. But you're definitely going to have a question just like this. We did this at the beginning of factoring. We did it at the end of factoring. It's on that packet as a review, and it's also on here. If I give you the zeros, the solutions, the roots, I want you to be able to work backwards, whether I give you fractions or not fractions. So these are the zeros, so remember to go backwards. You just do the opposite. If this is x equals negative 6, the factor is x plus 6, right? If the 0 is 2, the factor is x minus 2. So it's like going from the answers back to the original problem. And yes, I want you to FOIL that out. So number 4 you should have got. And again, they want you to write it equal to 0. So we're going to write this as x squared plus 6x minus 2x would be plus 4x in the middle minus 12 equals 0. Again, you should have questions. I'm just FOILing this out, combining like terms in my head.
Oh my goodness.
You should have example just like this, Austin, on your notes and in the packet. This is at least the 3rd time we've done this in class. I think the 4th time. Same thing on this one. Remember when it's a fraction. We've done a few of these too. When it's a fraction, every time you multiply this over. So you get 3x equals 2. You subtract the 2. So the factor would be 3x minus 2. If the 0 is negative 4, it would be x plus 4. Then you got to FOIL it out. Right? And that's the part, the multiplying part. That's just the end part. This part, getting to this part, really, really important. Okay?
So the number 4, that was it.
That's the answer. You just, it's like going backwards. Like look at number 2. They gave you the equation and you gave the solution. Number 4 and 5, they give you the solution and they want you to give the equation. Like you're just going in backwards order. And then on your test, you're going to have a section that's just like 6 through 10, where I want to know, do you know how to simplify imaginary numbers? Do you know how to multiply, add, subtract, and divide imaginary numbers? So number 6 is kind of just like number 3, except for not an equation. Simplify the negative square root of 80. Well, the negative is the I part. And then you have to think of perfect squares that multiply to give you 80. And that one's kind of a tough one. 8 and 10 work, but are 8 and 10, are either one of those a perfect square, Austin? No. So my advice is, don't break it up unless you can think of a perfect square. So you could pick 4. You could pick, what else is perfect squares?
40.
Is 40 a perfect square?
No.
No. What about 16? Is 16 a perfect square? Oh, so I always try to pick the highest one, but let's say you just picked 4, okay? This one, I'm going to go extra tough on this one, all right? Let's say you picked 4, and you rewrote this as, I'm going to just go ahead and take the I part out. That's negative. And then I rewrote this as 4 times 20. That works, but you always have to make sure it's completely broke down. Can you take another perfect square out of 20? Yeah, and so that's where 16 popped in my head, because I was like, well, if 4 works, I wonder if 16 works. Is 16 the perfect square? But if you didn't know that, you could say, okay, now I'm going to break up 20 as 4 and 5. So as soon as you broke it up enough that there's no more perfect squares, so I'm going to scribble out this 20. So I have the square root of 4 and the square root of 4. So that's like I times 2 times 2, because it's a perfect square. I can't take the 5 out. It's not a perfect square. So number 6, I think you should say 4i square root of 5. And if you broke that up as 16 and 5, you get that too. I don't know what to tell you.
So much information.
It's everything we've done. This will be a lot of information if on one day I taught you all of this, but we've spent 3 weeks, right? You were just complaining about how we haven't had a test in a month, because we've spent a month, 3 weeks actually, we've spent 3 weeks learning this day by day, and now we're reviewing it. It's not how it works. That's what our homework quizzes are. Life's not easy, Austin.
Easier than this.
Oh, I don't know. Number 7, if you multiply those first, you get the square root of 72. No I needed, but I do need to break that up. And again, think about your perfect squares when you're doing this. So maybe you think of 8 and 9. Do you think of 8 and 9? 8 times 9 is 72. Because 9 is a perfect square. Is there any more perfect squares there in 8? 4 and 2, right?
Yeah.
So just kind of be careful on that. I'm not going to try to give you super tricky ones. I like ones where it's really easy. Like we did one that was square root of 75, because that's 25 and 3. or I like giving you ones like 24 because you can break it up in 4 and 6. I try to give you ones that don't have these multiple levels in them yet, but just want to point out that really on number 7, you could break 8 up as, sorry, that's a 9, 4 and 2, so that would be 3 times 2 square root of 2, or 6 square root of 2 is what I think the answer should be. Adding and subtracting, multiplying with i's, just remember to watch your signs, combine like terms. Just giving you the answers really quick on these if you didn't. Most people in here didn't do most of these. But if you subtract this is like minus 17 minus a negative 12i. So I like to distribute my negative. So 6 minus 17 is negative 11. And negative 9i plus 12i is plus 3i. Not really a lot of work to show on the adding and subtracting ones. 9, that is not adding and subtracting. That's multiplying and dividing. Combine like terms. Remember that I squared equals negative 1. That's what we just did at the beginning of this week. So you have to FOIL that out. So you would get 56 plus 28i minus 24i minus 12i squared. FOIL, distributing, should feel pretty comfortable to you at this point. You should be able to distribute that, multiply. So then remember that this is negative 1, so that's going to become plus 12. So 56 plus 12 is 68. And 28i minus 24i is plus 4i. And then on Tuesday, we talked about this. There's not much to do here, but we don't like i's in the denominator. So this is where I want to know that you know to multiply by the conjugate. You have to multiply what's on the bottom, change the sign in the middle, and that will get rid of your i's on the bottom. So 2 plus I over 3 minus I, what am I going to multiply by? 3 plus I on the top and the bottom. And then that's a lot of multiplying too, right? And then you got to simplify the top and the bottom to go from there. The first number goes to both of these. So 2 times 3 is 6. 2 times I is 2i. And then the second number goes to both of them. So I times 3 is 3i, and I times I is I squared. You should always get 4 numbers if you have a binomial times a binomial. And on the bottom, that middle part should always cancel. So I would get 9 plus 3i minus 3i minus I squared. This is just minus 1, so I would get 5 plus 5i. And on the bottom, minus a negative 1 becomes plus 1. So I get 5 plus 5i over 10.
Well, wait, there's more.
We're not going to leave our answer like this if there's a common factor. And in this one, do you see that everything is divisible by 5? So the best answer here would be 1 plus 1i all over 2. Because you want to, this is a fraction. You want to simplify that fraction. Yes? You would miss a point. It's probably a 5-point question. So I would take a point off if you don't simplify your answer. Number 1 here, you should be able to cross out some answers here as you do this. Like for me, I would cross out D right away, because when you FOIL this out, it would be x squared minus 6x plus 9. I can see that does not have a y-intercept of 9, so I know that D is not the answer. You could do all the work to make the graph, or you could use the solutions to help you. The solutions are where it crosses the x-axis. So my solutions here are x equals 1 and x equals negative 3. That's what I get when I factor it. This is factorable if it crosses at nice points. So I would also cross out C as my answer right now, because can I multiply to get 3 and subtract to get 1 in the middle? Nope, so that's not it. So all I'm doing now is looking to which one of these will factor to give me these solutions. Again, notice that I'm not just circling an answer, I have some work to do. So if I was doing this on my test, I would make some parentheses on the top, and I would say, well, it's got to be 3 and 1. If I want a -2, it would be -3 and +1. When I solve those, are those going to give me these answers? Oh, be really careful there, right? Like, that's right, +1 minus 3, but when I solve that, doesn't that give me -1 and +3 because you do the opposite? So I think B is the answer because it's the only one left. B. Number 2 is just solving it, right? It's already factored for you. So solve this, you would get +1/2, +5. H is the answer. Number 3 is just like on the other paper, on the back side of this, we just did one like that. So I'm not going to do it right now. Number 4 is just like the one that we did on our homework the other day. You just add these together. So that's just 5 plus 2j. That's just F. I want to get to some of the stuff we haven't done. So really the only thing we haven't done that's on the other side. So if you didn't do most of this and I just went through all the answers, you should be able to go back and do that multiple choice I just skipped. You should be able to do this one. We just did one on the other side. We did one on the other side just like this with a max and a min. We did one just like this on the other side just now. So you could go back and practice those. What we didn't do on the other side that's also going to be on your test are these powers of I. And again, I think it's really easy. The easiest way to do it is to think about that clock. But that means that you kind of have to be able to reproduce this clock and say I to the 14th matches up with which of these, which you could just count. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Like, you could do that. I don't know if you'd want to do that with 85, which is why the shortcut is you think about the closest multiple of 5 and what the remainder would be left over. So do you agree that 12 is the closest number that's divisible by 4 in this problem? Like if you were doing multiples of 4, 4, 8, 12, 16, 20. Or another way to think of it is 4 goes into 14 how many times? With how many left over? Remember the good old day of like remainder 2? That remainder 2 is what tells you which one you land on. So it goes there, you could go around 3 times, and then you got 2 left over. 1, 2. So the answer here is the same as I squared, which you need to know equals -1. 85 is divisible by 4. 4 goes into 8 2 times. 4 goes into 5 1 time. With how many left over? 1. So it has a remainder of 1, which means it's the same as just I to the first, which is just I. Because there's 4 choices. There's only 4 options that could happen. 1, 2, 3, 4. And after those 4, it just repeats itself. So that's why we divide by 4, because every 4 times it goes around these options.
21 times, and then remainder 4. Whatever lands on.
So remainder 1, so this would be 21 times, and then 1 more. Which is why you really just need the remainder. So I cannot stress enough how much you should be practicing some of these problems, looking through that review packet. We are having a test on Monday, worth 100 points.